Good. So let's go ahead and get started. I've got, as you can see, I'm Eric Gross. I'm the co-founder of the Tech Academy, and welcome to our workshop. We're going to go all kind of nerdy tonight about electronics as they relate to computers. And before we get into anything, I just want to tell you, if you're at all interested in the industry of technology, the idea of either computer programming or being in some kind of a work role related to computers and programming, if that's an ecosystem that you're kind of interested in, I think you're in the right place. Because even though we're going to talk about electronics and not specifically here's how to program a computer, electronics has everything to do with you being a master of technology. And I don't mean in some kind of corny way. What I mean is technology just surrounds our lives. It like on every level, we are either subject to electronics and electronic devices being used to monitor us, or we use electronics and electronic devices to do productivity tools for us. We have electronics on our wrist or in our cell phone. Right now you're using your computer's electronics. The whole point is that technology is everywhere, and they are electronic machines. To the degree that you understand at least the fundamentals of how electronics applies to these computers, you can use them more effectively. Whether you're programming or not, whether you move into technology or not, you can use them more effectively. But if you do go into technology, understanding the role that electronics plays under the hood can make a tremendous difference in your effectiveness as a technology worker, as a programmer, an engineer. It's pretty cool. All right, enough of that. I'm obviously pretty passionate about this stuff, and you'll see why in a second. So this is me in my younger days when I had a little bit less gray hair. I'm a senior level software developer. And as it says there, I'm a U.S. military veteran. Now, this is why the subject tonight is near and dear to my heart. When I went into the Navy, an 18-year-old idiot a long time ago, I went into a program called the Nuclear Power Program. Now, Nuclear Power Program isn't all about nuclear weapons. Thank goodness. I wouldn't have done it. It's about taking nuclear power plants, nuclear reactors, and using them on a boat to provide every bit of energy that boat needs. Energy to move it through the water, energy to purify ocean water so you can drink it and take showers with it, energy to create electricity, which then is used to power all the electrical equipment on the boat. So that's what nuclear power is about in the Navy, right? But in that area of nuclear power, there's really 3 different jobs they would funnel you into based on your preference, not that they cared about your preference very much, or based on your aptitude, how well you tested. And so they funneled me into an area called electronics technician. So I was an electronics technician, nuclear, in the Navy. In other words, I lived and breathed this electronics stuff from a very, very early age. And what the Navy did really well is they were able to relate how electronics applies to computers in a very practical fashion. And that's what we're going to learn about tonight. So I'm also the co-founder of the Tech Academy. We put these free classes on to spread the word about who and what we are, and frankly, just to make technology better understood by people. All right. So we do have an assistant in the chat. Her name is Regina. She's awesome. Her role is to monitor the chat, answer questions, and boot you out of the class if you're really not a nice person. We haven't had that happen in a long time. Y'all are awesome. We get great people at these classes. Hey, absolutely. Good morning from Belgium. Good morning, she says. I'm glad you're here, Belgium. I mean, Lee from Belgium. Oh, and Lee likes Dallas. Okay, I'm going to take away my good morning, Lee. All right, good. So here I am making the point to be courteous to others, and I'm trashing people from Dallas. All right, so we have a chat. Clearly, I'm watching it, right? And so is Regina. Okay, good. Oh, I get it. So good. Lee is not saying she likes Dallas. I'm happy. All right, good. So on the chat, please do use it to send questions in to Regina. She'll do her best to help you out with anything you need help with during the chat. And we're gonna have a bit of a Q&A after we have our class, and we'll use the chat for that. For right now, we've already had a bunch of interaction in the chat. Normally, I would ask people to let me know where they're joining us from. We've already done all that, right? So look at the agenda here. a brief explanation of the Tech Academy and what we are. We're going to have our workshop about electronics. We'll have a brief Q&A. We'll give you some data about our coding boot camps, and we have a free gift at the end. People enjoy these free gifts. They're actually of value. They're real. They get sent to you in the mail. It's not like, here's a little ebook or a video you can watch. It's legit. It's pretty cool. Okay. By the way, the whole class is around an hour to hour and a half. And I encourage you, like I said, to stick around to the whole thing. You're going to learn a lot today, but it'll be approachable. It'll be pretty easy to understand. And the reason why is because of how we teach at the Tech Academy. Here's what we do. We run coding boot camps. Coding boot camps are intensive certification programs that are designed to prepare people for entry-level positions in the tech field. Typically, these programs last 3 to 6 months, and they focus on practical, modern skills, what's being used in the industry right now. And we've been offering very thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade now. In fact, next Saturday, about a week and a half from now, we're having our 10th anniversary party online. We'll give you links for that later on. You're all invited. It's pretty cool. So on to what we do. We have beginner-friendly certifications. This means our programs, not only are they cost-effective and self-paced coding boot camps, but they're tailored for beginners, people that have no prior technical or coding knowledge. And our certification programs thoroughly cover in-demand skills for the tech industry. They're endorsed by stellar online reviews, and they're designed to fit around your personal schedule, which makes them very, very flexible. And they're designed to prepare you for a tech career with a well-rounded toolkit. So that's what we're all about. All right, quick expectations, and then we're going to get into this. So what we will provide today is simple definitions for technical terms, and this is critical. One of the primary barriers to moving into the technology industry is, and more on this later, a lot of the available explanations of some of the concepts and terms and symbols involved are unnecessarily complex. And it's a barrier for people being able to understand this. I want to assure you, there's nothing about technology and computers and programming that any reasonably bright person who can read, write, and do basic math, there's nothing you can't learn. And the apparent complexity of the subject is very often due to really poor definitions of the key terminology involved. We handle that. We'll explain these technology concepts in plain English. Now, on this class, there is no coding, but we do, in fact, offer free coding classes where you kind of get your hands dirty. They're a lot of fun. At the end of the class here, we'll provide links to those. In fact, Regina, if you have it handy, can you post a link to our next free class in the chat so people can have that? Because I'd love to see people with these coding classes. They're awesome. There you go. She just dropped that in, okay? I'm going to give you a second to grab that link. It'll take you to the meetup page. And if you want to register real quick for that coding class, I'd love to see you there. They're a lot of fun and very educational. If you haven't noticed, I'm pretty passionate about teaching people about coding and computers. All right. I'm going to stop sharing for a moment. We're going to switch over to the slide that has my actual presentation on it. All right. So this is all about the basics of electronics and transistors. And by the way, I'll explain what a transistor is, just so you're not hung up on that whole thing. It's a tiny, tiny electronic part inside a computer. We'll leave it there for now. We're going to fully explain it during this class. So let's look at this. We'll start with, oh, and by the way, notice on the bottom right side of this screen is a light gray box just below the Tech Academy logo. We put that little gray box there so you can move my picture, because Zoom is probably showing you my picture as I yap my mouth. You can move that little video down to that bottom right gray box, and you'll never be covering up any of the information we're going over. So use that box if you need to. All right, so I'm going to start with the definition of electronics. Electronics is the study of electricity and how to use it to build things. That's all electronics is. You can get super complex about it. People get very nerdy about it. And when you have people that are thoroughly educated in electronics try to explain it to you, you'll promptly fall asleep. That's all electricity or electronics is. The study of electricity, how to use it to build things. That's all it is. So why are we talking about this in the context of computers? I mean, yes, we all know that computers take in electricity. But the fact of the matter is that these machines called computers, not only would they never do any work if we didn't put electricity into them, but when it comes to electronics, which is study of electricity and how to use it to build things, that is exactly what computers are all about. We're taking electricity in and we're building a device that can accomplish the purpose of a computer. What's the purpose of a computer? I'm actually going to stop here for a minute. I got an opportunity to have a little fun here. If you have attended my classes in the past, I want you to throw into chat, what is the purpose of a computer? See if anybody can remember that. What's the purpose of a computer? Good. Lee says to do work. Yes. We're going to flesh that out a little bit. Absolutely. Anybody got a little more nuanced data or explanation of that? And by the way, you're 100% right, Lee. It is to do work. All right. So here's what it is. The purpose of a computer is to take in data, process that data in some way, and then send the data on. At its most fundamental, that is all a computer is there for, is to take in some information, some data, to work with that information or data in some way, and then send it on. Take in data, process it, send it on. So this is why the subject of electronics has everything to do with computers, is because we need machines that can do those three things, that have a physical way to take in data. They've got a physical way of representing data inside this machine. They have a physical way of modifying or processing that data, and they have a physical way to send the data on somewhere else. And what we're going to learn tonight is, how does the computer actually do that? We all know that computers work with data. We use them all day long. Someone will send us a file via email. That's data. We'll pop it open and read it. We'll print it. We'll turn it into a PDF. We'll forward the email to someone else. We know that we're working with data, but how does it actually happen down inside these magic boxes called computers? This is why electronics are inherently important to the idea of computers and the technology industry. Now, I'll speak very briefly about my experience in this area. As I said, I was an electronics technician in the Navy and learned, here's what I learned is, and we're going to cover a lot of this tonight, all the way down to the individual pieces of metal inside a computer. I learned exactly how a computer can take in some information. Like, how do you get information to a computer? Physically, what do you have to do? Almost so you can watch it occur. I learned how you can take in information that's inside a computer and do things with it. Sort it alphabetically, add to the data, create new items of data yourself. And I learned physically, how do you take data that's inside a computer and send it somewhere? So when I started using computers for programming later on in life, there was no mystery about what it was doing under the hood. And that's why I love this class, because I do not want you to have mystery about these magic boxes called computers. There's nothing magic about them. It all comes down to simple concepts. All right. Let's first talk about, in terms of electricity, the idea of a conductor. We said that electronics is all about the study of electricity and how to use it to build things. This is one of the first things you need to know about in order to build something that uses electricity. A conductor is a material that allows electricity to flow through it relatively easily. Now, I said relatively easily because every different material that is capable of letting electricity flow through it does so more or less easily than any other material. Some of the things that are really easy for electricity to pass through are gold and silver and copper. These metals are very easy for electricity to pass through. Steel, it's easy, but it's not as easy for electricity to get through that kind of metal as it is for the other three. Seawater, absolutely, electricity can pass through it, but it's a lot harder for electricity to move through it than the other items here. So the point here is that not all conductors are made the same, but they all have the important purpose of we need to get electricity from one point to another. So we need to have some material that's at least capable of letting electricity move through it. So that's the first principle. We have a nice little graphic there that shows electricity actually traveling through the air. And this is the last thing I want to mention. I said that there's varying levels for different materials of how easily electricity will pass through them. One of the hardest things for electricity to pass through is the air. But it's totally possible for it to happen. We've all reached out and gotten shocked by something and seen a little spark of electricity travel through the air. It can, in fact, happen. Okay. Lee has a really great quote here. It's one of my favorite quotes. It says, someone well known, I'm blanking on the name, said something like, technology, when first introduced, is indistinguishable from magic. And if we look up Arthur C. Clarke, technology magic, any sufficiently advanced technology is indistinguishable from magic. And that's Arthur C. Clarke, who is just a very famous science fiction author. He's fantastic. So thank you. That's awesome. Oh, Hitchhiker's Guide. No, it isn't from Hitchhiker's Guide to the Galaxy, which is one of the best books ever made in the history of forever. Okay, good. So we covered this idea of conductors. Now, you've got the opposite. You have insulators. These are things where it's very hard for electricity to go through them. They're things like rubber, glass, oil, diamonds, dry wood. Why dry? Why do we specify that? Because wet wood, it's got water in it. Soaked into that wood, electricity goes through water a lot more easily. So a wet piece of wood can conduct electricity a little more easily. So it's just two sides of the same coin. An insulator is shifted all the way over to that, the point of view where it's useful. It's practically useful in the real world to try to stop electricity from getting anywhere. Now, why do we care about this? Inside a computer, you're going to have a ton of metal, these little wires that are taking electricity from one point to another. Very often, these wires are very close together. Now, we mentioned already that air can, in fact, allow electricity to pass through it. It's really hard, but it's possible. One way you can make it really easy for electricity to pass through the air is to take two things that have electricity in them and put them really close together. So we've got this problem inside computers. Lots of tiny parts, lots of tiny metal parts that are of necessity packed in really close to each other. So we need a material to put in between the individual wires that is specifically designed not to let electricity through, so that each wire that's carrying electricity can operate on its own. That's what insulators are for. And again, there's lots of different varieties of materials you can use, but that's why we care. All right, now let's talk about circuit. This is where we're starting to get really practical. So far, we've talked about, okay, fine, electricity, and you've got some materials that electricity can flow through, blah, blah, blah. The fact is, electricity is only valuable because it does work for us. How do we get electricity to do work for us? We make a fully connected set of conductors, wires, like a loop with wires, and we put two things into the loop. One, something that makes electricity. That's what the battery is on the left. The battery makes electricity. And two, in that loop, we put something that needs electricity, something that could do work as long as you gave it some energy, as long as you give it some electricity. Now, the important aspect to grasp about this whole thing is electricity will not move through something and do any work in that thing unless there's a complete path for electricity to travel. Notice on that battery, we have a wire coming out of the positive bump on it and then traveling over through the light and then back through this physical device called a switch, and then back to the negative part of the battery. So it's a complete loop. Now, what are these blue things that are moving? Those are electrons. Now, there's a lot of competing schools of thought about the exact way that electrons move inside of wires. We're not going to get super nerdy about that. In fact, anybody who tries to get super nerdy about that, and all they're trying to teach you about is computers, is just being unnecessarily nerdy. All you need to know is this. When electrons move through wire and through machines that need electricity, the machine can do some work. The machine here is the light bulb. Electrons are moving through that light bulb. Now, I don't care whether they move through in one direction or the other direction. There's competing schools of thought about it. We get the electrons to move. The light bulb does its job. It turns on. How does this apply to computers? We're going to use inside the computer. This is critical. What I'm about to tell you is probably the most important piece of data I will cover during the entire night. Inside the computer, the way we represent data is this simple. On a specific piece of wire, a specific circuit, is electricity moving through the circuit or is it not? That is the only way a computer can actually have data in it. A computer doesn't understand the word cat or the number 55. It only understands, is electricity actually flowing through any specific circuit that I have inside me? Or is electricity not flowing? And the most amazing thing about computers is from that one very real physical universe thing, is electricity flowing or not, we can represent millions of types of data. We can accomplish the purpose of a computer, which is to take in data, process it in some way, and then send it on, all based on the yes or no question at any moment in time for a specific circuit inside the computer. Is electricity moving in that circuit or is it not moving in that circuit? That is the basis for the entire operation of a computer. Now, as an aside, the fact that computers are so cut and dry that there's simply a yes or no question built into the very way they operate sometimes can make computer nerds and programmers and engineers be very like yes or no, true or false thinking. That's a whole separate subject. All right, so that's a circuit, a complete path for electricity to flow in that can do work. Now let's talk about this little thing that keeps moving at the bottom of the screen because it's critical. I call it a switch. It switches electricity on or it switches electricity off. What we're looking at here is an actual handle that we can lift up or down and control the electricity. Any guesses to what that black thing on the end of the moving handle represents? Throw it in chat if you have an idea of what that black thing on the end of the handle represents. It's important, actually. It's a piece of rubber. An insulator. Yes, exactly, Lee. It's an insulator. It's a non-conductive material. That's actually the more precise answer. Love it, Matthew. Why? Because that thing down at the bottom, that switch, that symbol was not chosen at random. This is a very real device that exists in the real world. Some of you have used them before. It's literally two metal posts, one on either end, and a bar that you can lift up or push down. And when you push it down, you complete the path for electricity to flow. This is how you control. Remember what I said, that the entire basis the computer works on is whether or not electricity is flowing in a circuit. The switch is how you control that. They can be kind of small, like little teeny, maybe a quarter of an inch across. They can be really huge, 1.5 feet or 2 feet long. You make them bigger when the amount of electricity that needs to go through them is much higher. And you can make them very small when the amount of electricity needs to go through them is very small. Any ideas why they need to be very big pieces of metal if they're going to carry more electricity? Bigger, thicker pieces of metal if they're going to carry more electricity. Here's the reason why. When electricity moves through metal, it heats up the metal. Oh, that's good. Geneva says some more electrons can fit in the conductor, so the electricity can be stronger. That's true as well. The very practical reason why we need to make those, if we're going to put a lot of electricity through something, why we need a thick piece of metal for it, is because when electricity flows through metal, it makes the metal get really hot. The smaller the piece of metal, the hotter it's going to get if you keep the electricity the same. So why do we care about that? Well, inside computers, I already said we're dealing with very, very small wires. So the electricity that can go through the wires has to be really, really low, or it'll literally make that wire so hot it'll burn and it'll evaporate. It'll break. And that's fine. That makes sense for the wire. We're sending electricity through a wire. We better make sure it can handle the amount of electricity. Same thing, though, is true for the switch. We need switches that are very, very small. This is all going to come. I'm going through this for a reason. You'll see it in a few moments. The switches that we use inside computers that are going to basically determine whether or not electricity is flowing, which determines whether we're representing something as on or off, true or false, 1 or 0. These switches are very small. They're so small, in fact, that they cannot be mechanical. They can't be something that you actually physically can move. And we're going to come to that in a moment. All right, so let's talk about a circuit board. Remember that I said a circuit is a complete path for electricity to flow that has some item in it or items that can do work when electricity goes through them. We'll go back up. Here is a complete path for electricity to flow that has an item in it called a light bulb that can do work, which is generate light for people to see. A circuit could have 2 or 10 or 100 different things in that loop that do work. We see this in our houses. We know that, like, if the electricity stops at our breaker panel in the house, sometimes 3 or 4 different lights all in one room no longer work. It's because they were all on the same circuit. The electricity went away from that circuit, all of those lights don't work. So this is a circuit. So circuit board is a physical board that has a bunch of circuits on it. It's right there in the name. Now, it is a little more complex than that. But you have to start right there. A physical board is a material. You can pick it up and hold it. And it has a lot of little teeny circuits on it. It has a lot of little teeny complete paths, and they're all separate from each other. A complete path that electricity can go through, and along the way are things that can use that electricity to do work. So these boards have a large number of these individual circuits on them. That's what a circuit board is. They're typically made of, really hard, durable materials. And they're made of materials that are not conductors. They're made of materials that are, in fact, quite resistant to electricity flowing through them. They're insulators. That's the material they're made out of. And then we insert into the board the little wires, the conductors that make up our circuit. We insert into the board the little teeny pieces that do the actual work, the little pieces that need electricity to do their work. They all get inserted into the board. That's what a circuit board is. And you can see them inside of your computer. Many of you have seen one of these. If you've ever taken the side panel off of one of your desktop computers, you'll see circuit boards inside there. On the biggest circuit board in your computer is the most important piece in your computer. It's called a chip. We also call it a central processing unit. Now, a chip is also a circuit board. It's a physical piece. It's a physical device. It's got a bunch of little circuits on it, but it's got a special purpose. So we give it a special name. Its purpose is to hold all of the circuits, all these little electronic circuits that do the primary work of the computer. Remember, the purpose of a computer is to take in data, process that data in some way, and send it on. That's the purpose of the computer. It's this one set of circuits, all on this physical board called a chip. That's what accomplishes that work. All right, we're getting towards the end here. I mentioned before that we need a way to control whether or not electricity is flowing in any one of these circuits inside a computer. The fact is, modern computers contain between 3 and 5 billion circuits. There's a lot of circuits inside a computer, and they all have different purposes. That's beyond the scope of the class we're teaching tonight, okay? There's a lot of them, and they're very small. So we need some way for these tiny, tiny, tiny circuits to control whether or not at any given point in time electricity is flowing through them. And the way we accomplish that all starts with a really cool material called silicon. Silicon is a naturally occurring element. You can find it like on beaches in sand. Many of the pieces of material that make up sand on a beach, lots of them are this element called silicon. Lots of them are rocks that are broken up into small pieces, but a lot of them are this element called silicon. Silicon, and we're going to break this open in some detail. Silicon is wonderful because when you melt it down and turn it into, it turns into tiny pieces of metal. Well, it's not 100% metal. It's not 100% not metal. Silicon's amazing because you can control whether or not it conducts electricity. I just got to stop for a second. I just want you to think about that. Before, we were talking about things that either do or don't pass electricity well, and that's it. Wire, yes, electricity goes through it really well. A rock, a big piece of wood that's dry, no, electricity is not going to go well through that. What if there were a material where you could control with precision whether or not it actually passed electricity through it? That's amazing. And that's what silicon does for us. Let's explore how. The primary way we do this, whether we control, yes, electricity is flowing in a circuit, no, it's not, is through a device called a transistor. A transistor is an electronic component that is controllable in that we can control whether or not electricity goes through it. This is what they actually physically look like. On the left, you can see what one would look like if you're going to hold it in your hand. On the right is what's inside it. Notice on the left, we have these 3 metal pieces coming out. Those metal pieces correspond to the blue, magenta, and purple elements on the right. Notice that those black moving things are electrons. So electricity is moving from the blue part of this device, which is, say, the left-hand wire, through the inside of it, where the light blue and green is, and out the purple. So remember, we're talking about switches. Electricity is on one side. Electricity could be on the other side. How do we control whether or not it passes through and goes to the other side? That's all a switch is. Transistors are electronic switches. They're switches with no moving parts. Shut the front door. How amazing is that? They're not going to wear out over time like a mechanical switch would. They can be really, really small. They're amazing. But how do they actually do that? How do we take this tiny thing with no moving parts and control whether or not electricity actually goes through it? The secret is that little wire in the middle, the pink one. Silicon is really cool in that if you build it perfectly, if you take those little pieces of silicon, melt them down, and add in a little bit of other metals to it, usually a metal called germanium. It's really rare, but you can find it in rocks. If you add a little teeny bit of it, now something cool happens. And here's specifically what happens. If you warm up that little piece of silicon, suddenly it allows electricity to go through it. And if you cool that piece of silicon down, now it will not let electricity go through it. And suddenly you have a way to control whether or not electricity is flowing with no moving parts and in a very small package. This is why Intel makes billions and billions of dollars a year. And all these other, they call them semiconductor companies, why they make money. Silicon is a semiconductor. It's a material that can either conduct electricity or not conduct electricity based under your control. So how do you control it? How do you warm it up or cool it down? It's simple. On that little middle wire, if you want to warm it up, put a little teeny bit of electricity on that middle wire. The electricity will go into the silicon and warm it up. And suddenly electricity will go through it. You want to stop electricity from going through? Remove the electricity from the middle wire. The silicon will very quickly cool down and stop the flow of electricity. And that's what we have represented here. On that little pink piece in the middle, when you start to see those positives apply, that's electricity being applied to that piece of metal. More and more of it. It warms up the green part. And then electricity goes through the green part and flows through. Now, there's a lot more nerdy science behind it. If you're going to work for an actual chip manufacturer, you learn all kinds of stuff about it. But for the purpose of being a computer programmer, an engineer, a technologist, somebody working in the technology industry, all you need to know is this. 1, the purpose of a computer is to take in data, process the data, and pass on the data. 2, we represent data in a computer by whether or not on any specific circuit electricity is flowing or not. And 3, the way we control whether electricity is flowing or not is these tiny devices called transistors. That's all you need to know. What does it mean? It means we can make computers with billions of electronic circuits in them that are super small, and the component, the transistor, that controls whether or not electricity is in it or not, that controls the data in that circuit, is a tiny, tiny piece of material with no moving parts. That isn't magic, but it almost sounds like it. Okay, good. So that's a transistor. Let's flesh this out by explaining a little bit more of how it might work. What you are looking at right here is an actual circuit. In the middle, that funny thing with flat on one side and then a curve on the other, that is a transistor. It's a special kind of transistor. And here's what the transistor does. It takes electricity in from two sources on the left. The two sources, you can see them. They're like light switches. Now, there's no little flip switches inside a computer. That's not what we're saying. We're just saying that inside a computer, you could have two wires. They come together and they go to the input on the left side of a transistor. This specific transistor, and I'm sorry, this stuff, I know I'm a nerd. I get it. This is amazing. You're looking at a circuit that is able to figure out the following. If two things are true, then the result is true. Okay, fine. What are you talking about, Eric? Let's say we're writing a computer program and someone, let's say, to be eligible to join a specific class at a college, they need to be both a junior or greater, like a junior or senior, and their grade point average needs to be above 3.8. That's a pretty realistic thing. There might be certain classes at a university where you've got to be at least a junior, and you also have to have at least a 3.8 grade point average or higher. How does that relate to what we're looking at? On the left, those two wires coming in, the top one could represent, is the person a junior or not? Are they a junior or higher, or are they not? It's a pretty cut and dry question. It's yes or no. It's true or false. The bottom wire, B right there, represents, is their grade point average 3.8 or higher or not? That's it. That's a simple thing. You can build that kind of data in a computer. So when you take those two pieces of data and you need in your computer program to decide, am I allowing student Jane Doe to enter this class or not? This is the circuit that does it. Those two signals come in on the left-hand side. And that circuit, that transistor, is built so that only if there are, in fact, if there's electricity on both of those incoming wires, only then will it send electricity out the other side. This is a circuit that allows you to make decisions. One of the primary things we do in computer programs. And this is how simple it is. This transistor, the thing in the middle, it's just a few electronic circuits. It takes in two signals of electricity. And if they're both present, then it sends electricity out the other side. Boom. We have the ability to make decisions in our computer program. So when you're writing programs and you write, if age greater than 21 and you're a smoker, therefore you're allowed to come into the cigar lounge, this is what's actually occurring inside your computer. There's no magic to it. It's just simply, let's control whether or not electricity is on one of the wires based on one of the criteria. Are they greater than 21? And let's control whether or not electricity is on the second wire based on the second criteria. Are they a smoker? And if both of them are true, then let's set allowed to enter the cigar lounge to true. In other words, let's put electricity on the output wire. This is how computers work. Now, there's several other examples of different circuits. I'm not going to go through them in as much detail because I think you'll get the picture. Here's another one. This is a circuit that just simply switches whether something's true or false. If there's electricity coming in, then there's no electricity coming out. If there isn't electricity coming in, then there is electricity coming out. This is how you reverse something that was true and make it false. Here's another one that will only allow electricity through once it's been turned on. Oh, wait, this is a This is another, I think it's switches. Yeah, it's just another switch. All right, this one's really cool. I'm not going to spend a ton of time on this because it'll take a while. This is a type of operation called an exclusive OR. Let's get all nerdy about this. When you're talking in plain English, you could say, look, either you're a faculty member, so you're allowed in the faculty lounge, or you're a student who's a leader of student government, so you're allowed in the faculty lounge. But you can't be both. That doesn't make sense, does it? No one is both a professor and also a student who is a student leader. So this circuit represents that. You're either true for one thing or true for the other. And if either one is true, then yes, we'll say the output is positive. The output's yes. That's what this circuit represents. The thing I'm trying to illustrate with these different circuits on the page is just that when you're doing your programs, when you're writing all this stuff that looks like English and says, if this, then that, all that's happening inside the hood is under the hood. I mean, in the computer is we are controlling whether or not electricity is present on specific wires at any given point in time. That's all we're doing. And based on whether the electricity is or isn't present, we are applying electricity to other wires or we're not. That's all that's going on inside a computer. Now, admittedly, these types of things are happening at the rate of 2 to 4 billion times a second. So it makes the computer seem all powerful and complex, but that's all that's happening. Geneva has a great question. She says, are these logic gates? Yes, they are. I didn't want to get too deep on that. A gate is a transistor that allows electricity to go through or doesn't. That's all a gate is. And there's different types based on whether you want to say, are two things together equal? Is only one of them? Or are two things true? Is only one thing true? There's different types of logic gates. But yeah, that's what these are. That was a great question. All right, so here's the last thing I want to say. I've skimmed the surface on this. I've tried to relate how electronics and the concept of a transistor and representing data with electricity works inside a computer. There's no way to do it justice in a presentation this short. I just want to open up your eyes to it. Every boot camp that we offer has as its first class what's called the Computer Basics course. And we break this apart really well. It doesn't take forever. It takes a few hours to fully understand this, but we make sure we include this on the very first training every boot camp attendee does, because once you understand this well, your ability to program computers skyrockets. There's no mystery in your mind at all when you write out a specific instruction in one of your programs, exactly what's happening under the hood. And I got to tell you, it's a very calming bit of knowledge to grasp. All right, don't go anywhere. Let me switch to the next part of my presentation. Okay, so I took a little bit of time on that, and I'm glad I did. I hope you enjoyed it. I've got time for maybe 1-2 questions. Regina, do we have anything interesting in the chat that I haven't captured so far?
There were 2 questions earlier. If you scroll up the chat, you just answered the logic one.
I think we've got it. There might be. I know in the middle of that, Lee was asking about. Go ahead.
Yep. I was just gonna say we got another one. Are switches transistors?
No, it's the other way around. A transistor is a switch. A switch is any device capable of controlling whether or not electricity flows through a circuit. Like when you go into your house and you flip a light switch, that is in fact a switch. A switch is a very general term in electronics for any device, whether or not it has moving parts that can control whether or not electricity flows in a circuit. So the correct way to say this, by the way, Geneva, that's a great question. Correct way to say that is all transistors are switches. but not all switches are transistors. Switches take many forms. Does that answer your question, Geneva? Awesome. Okay, good. Okay, cool. So you're going to, if there are other questions that either you have thought of that I haven't gotten to, or that you think of over the next couple of days, we're going to give you an email here in a little while where you can actually get a hold of us. It relates to our free gift. So it's totally fine for you to send questions in for me. They always get forwarded to me. I always answer them. I love answering these questions. All right. So let's talk a bit about like who and what we are. So this is who and what we are. We provide coding boot camps. In fact, we have 12 online boot camps. They cover a wide range of tech subjects, including artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. There's a lot there. In fact, we have more certification programs than any other coding boot camp on earth. And here's how our programs work. Our boot camps are self-paced, but they're also instructor supported, which is quite an accomplishment. They're flexible because students can set their own schedule and they can enroll 365 days a year. You don't have to wait till classes start on a specific day. The content we provide on each bootcamp is very well-rounded. It's very in-depth. With more about that later. Our bootcamps are affordable. In fact, they're priced under the national average. All of our programs include job placement training and job placement assistance. And most importantly, our programs are designed for absolute beginners. No technology knowledge or coding experience is required to get into and through our boot camps. So you don't have to be a nerd. Yes, I am a self-acknowledged nerd, but you do not have to be one to get through our programs. It helps because you get my stupid jokes that I put into the curriculum, but that's about the only advantage. We consistently land on every major best coding bootcamp list. These awards are given out by a lot of different organizations every year, and we're always on these lists. Our average review rating across all the major bootcamp review websites and the big places like Facebook and Google is 4.8 out of 5 stars. We're super proud of that. And this is based on student and graduate feedback. We can't influence this at all. This is really cool. So now I want to just kind of ask you a couple of questions, like the questions about like why working in tech. It may be for you, it may not. I've asked you to look at a couple of different things. Technology has a really good work-life balance. I could expound upon that in detail. We're probably going to do some presentations pretty soon about a day in the life of a developer, right? And I'll be able to talk about that in a lot more detail. But work-life balance in technology is really good. Yes, you're working, but you're not working 80 hours a week. You're not doing demanding physical labor. And you can do remote work a lot of the time. The industry is very accommodating of remote work. The tech industry is also a very creative industry, even though we just get all nerdy about the logic, true, false, yes or no, electricity, machines. The fact is, we use these machines, which are very mechanical, very electrical, very logic-based. We use them to solve problems for real human beings. And there's so much room for creativity in that space. And when you get done solving a real, complex problem, there's tremendous personal pride in the work that you've done. And finally, technology is a very stable industry. It invades every aspect of society. And there's a ton of different roles. You saw all those different boot camps. There's a lot of different roles in technology. They pay really, really well. And over time, as you get better at your job, there are regular increases in pay. The ceiling is very high in technology. But there are, in fact, barriers. You might be thinking to yourself, okay, fine, this could cost a lot of money. And the fact is, boot camps do cost thousands of dollars. I'm not going to misrepresent that to you at all, right? Now, there's a reason for it. You're getting 4 to 6 months of absolutely intensive training, which can utterly change your life. More on that about how much people earn afterwards, but it can cost a lot of money. There are multiple financing options that we provide. We have upfront discounts. We even have monthly payment options if you have no credit or bad credit, right? We have a tuition option for everyone, no matter what your financial condition. There's a way to figure it out. And the fact is, getting through a coding bootcamp at the Tech Academy is an investment in yourself. You are making yourself more valuable and your earning power will go up. Another thing you might be thinking of is like, okay, look, I've got a family. I've got a full-time job. Like, I've got commitments. I don't have the time to do this. It'd be so challenging. And you're absolutely right. It does require a time investment. And another thing you might find is that some of these boot camps out there, they operate by cohorts, meaning they'll, take their applicants, make them all wait until a certain day, and then that whole group, they call it a cohort, will move through the boot camp all at the same time at the same pace. That makes it even harder to manage time-wise. Some boot camps require you to be in person. You have to go into their campus, which involves travel, and if you're nowhere near them, makes it practically impossible. We've tried to solve all those problems through this. With our programs, you choose your study schedule. Part-time study is allowed, which means you can study concurrently to going to school or doing your job. Finally, there's the aspect of your technical interest and ability. You may have already encountered this. Some technology educational materials are frankly too hard for beginners. They don't need to be, and it's a separate subject, but they can be too hard. A lot of the times when you're trying to learn this, you'll find that the educators assume too much prior knowledge on the part of the student, which is a huge barrier. With the Tech Academy programs, you don't have to be a nerd. We've broken down that barrier. You don't need to have any technical background in order to enroll and get through the programs. So, I have a question. Are you like working a dead-end job? Or are you unemployed? You have a strong desire to work from home or to materially change your work-life balance? Do you want more time with your loved ones? The real question is it time for a career change? And if it is, the Tech Academy is the solution. We are career change experts. Our logo is a bridge on purpose. We want to cross that chasm between lack of knowledge of technology and being the effect of it to great knowledge of technology and being able to leverage that knowledge to make a great living. This bridge is the route into tech for everyone. At this point, we have over a decade of experience in helping people break into tech. Most of our graduates, they make $30 an hour on average in their first job. Look, there's no guarantees of anything, but when you apply yourself and you get through one of our programs, and especially if you'll take the training on job placement and really work hard with our job placement specialists, when you get these jobs, $30 an hour equates to $60,000 a year. And that's just the average. If you've got prior history, if you've been working in the, out in the field for a while, if you're doing a career change in your 30s or 40s, you probably earn more, right? The truth is that we already have over 1,000 graduates working in tech everywhere, from small businesses all the way to the big dogs. They have technical positions at Nike or Facebook or Disney or Uber or Epic Games, right? So is this a reminder? We offer open enrollment. You can start anytime. If anything about what you've seen tonight resonates with you, if it seems like tech is for you, you owe it to yourself to enroll now. So how do you do that? You go here. learncodinganywhere.com/Eric. It's Eric with a K because that's the correct way to spell that word. On there is a very short form to fill out. It's like 4 fields on it. And once you've done that, there's a series of steps that will tell you everything you need to know about the Tech Academy. There's videos, articles. There's even an optional step to book a call with our admissions specialist to get any of your questions answered. So I'd encourage you to fill out the form. And after the event, go through and complete those steps. Even doing those steps will educate you in technology. But more importantly, it'll tell you enough about the school for you to be able to make an informed decision. So I'm going to stop right now and encourage you to fill out the form. I'll wait for just a second while I get a drink of water as well. So we'll wait for a minute here. And stick around because I have a free gift coming your way. By the way, if you go to that link and you're taken to a login form, it just means you already have an account with us. And you'll see, if you don't know it already, how to get in with the password down at the bottom. All right, a couple really cool things here. Since our graduates really love us, referrals have always been one of the top enrollment sources for us. And we've always paid commissions to graduates who refer their friends to the school. But that program is open to anyone. We pay a 5% commission for all enrollments that result from a referral, which means you can refer your friends. And if they sign up, we'll give you a 5% commission check. So in a moment, we'll have an email address you can use to email for your free gift. If there's someone you're thinking of that you really think we should be talking to, put their name and contact data in there. We'll register that you referred them. And if they sign up, we'll cut you a check for 5%. All right. So our school, our co-founders, actually, Jack and I, we have 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and You Are Not Stupid, which we're super proud of. You Are Not Stupid is basically, I referred to this earlier, it's a version of that computer basics course, the first course everyone does on our boot camp. We've taken all the content of that course. We've taken and explained all modern technology terms and concepts, and we've even added in this book a history of tech that shows how we arrived at where we are today. This will remove all mystery from computers and technology for you. And frankly, whatever relative you have that is always asking you to be their tech support person just because you can spell World Wide Web, give them this book and make them read it, and you won't be their tech support person anymore. All right, so we talked about a free gift. This project management handbook is our free gift to you, and it is a actual, real, physical book that will be sent to you. Now, unfortunately, this is for US only. If you're joining us from out of the United States, I'm sorry, we can't ship overseas. But if you're in the US and you want a copy of this book, it's this simple. Regina's put an email in the chat, books@learncodinganywhere.com. Send us an email, and this is vital. You have to include your actual mailing address. We are literally going to send you a copy of our book. It's a physical book. You can pick it up and read it with your eyes in your hands. So give us your address if you want the book, right? Also in that email, you can send any other questions I didn't answer tonight. You can send any referrals as well. So I'm going to pause for a moment and give anybody who wants to send that email a chance. Regina, I think I know the answer to that. We don't do Canada, do we?
We don't.
Yeah, I'm sorry,
unfortunately.
You can find it on Amazon. We sold about 20,000 copies of our books across all those different titles. You can find it on Amazon and get it super cheap, and they'll send it to you in Canada. I'm sorry, Mahmoud. It's Mahmoud, isn't it? Did I pronounce that correctly? Okay, so that's the free gift. Please get it. We want you to have this. This is a really good book that explains how software is made. If you're ever wondering, like, what is the life of a software engineer and the development team? Oh, good. Thanks, Mahmoud. Right? What's it like to make software? You get all that insight in here because it's all about managing the process of making software. It's pretty cool. Okay. Now, I mentioned links. You can get all Tech Academy links in one location. Regina's going to drop this Linktree link in the chat. When you go there, you have access to everything. You have links to our free educational YouTube playlist. We got a bunch of free educational YouTube videos. You got links to our books and dictionary, upcoming meetups. If you want to know what our upcoming classes are, you can go there. And of course, there's links to all our social media accounts. So follow us on social media. Invite your friends to future meetups. And if you'd like an opportunity to win a copy of You Are Not Stupid, we give that one a week out to people who will do the following. If you want to have a chance to win this, if you'll share a link to our next event, remember you can get that by going to Linktree. If you'll share a link to our next event on social media and you'll tag us, of course, we'll notice the tag because it gives us a notification. Everybody who does that during any given week, we throw them in a hat, we pull out a name at random, and we send them a free copy of You Are Not Stupid. So you'll be entered to win that. And it really is a good book. And so we'll announce our winner at our next event. And that's what we have. Thank you so much for attending. I hope this was helpful. If you want more like this, attend our free classes. If this school seems like the right fit for you, click on that link right there and apply. We'd love to have you at the Tech Academy. Other than that, I will see you at the next event. I'll stick around for a second, see if any cool questions come in the chat. But that's the end of our class. You're welcome, Geneva. I'm glad it helped. Appreciate that, Lee. Absolutely, Mahmood. Yep. Bye-bye, folks. You're welcome, Crystal. Good to see you. All right. Good night, all. See you next time.